Good morning all of you. Myself Ravan Kumar, Assistant Professor in Mathematics HNS Department. I have 18 years experience. Today we are discussing about the topic regarding eigenvalues and eigenvectors. Today we discuss the topic eigenvalues and eigenvectors of a matrix. Eigenvalues and eigenvectors of a matrix. Okay, first of all, we discuss about the eigenvalues and eigenvectors. Before going to the definition of eigenvalues and eigenvectors, first of all, we know the definition and concepts of matrices. First of all, we will briefly discuss about the matrices. Already we are studied in lower classes well about matrices. First of all, simple. I am explaining the basic definitions. What are the types of matrices discussed here first. First of all, what is a matrix? Matrix, the arrangement of elements in the form of rows and columns. The arrangement of elements in the form of rows and columns. Elements is nothing but A, B, C, D, E, F, whatever it may be. Are 1, 2, 3, 2, 4, 6. Elements are numbers. Well, basically it is elements which are arranged in the form of rows and columns. That is rows and columns. Here this first row and this is the second row. And first column, second column, third column. Here also first row, second row. First column, second column, third column. That is called as a matrix. It is called as a matrix. The arrangement of elements in the form of rows and columns are called as a matrix. That is the definition of a matrix. After that, what is the order of a matrix? First, discuss about the order of a matrix. Order means the number of rows by number of columns. But the matrix which consisting of how many rows and how many columns. The matrix which consisting of how many rows and how many columns. That is called as the order of a matrix or size of a matrix. Order of a matrix, otherwise it is also called as a size of a matrix. Suppose I take this matrix A, which is considered as I am taken as a A, which consisting of how many rows? 2 rows. And how many columns? 3 columns. The order of the matrix is 2 by 3. The order of the matrix is 2 by 3, which consisting of 2 rows and 2 columns. First you have to write the row size number and after that the column size number. But that is 2 by 3, which can be read as 2 by 3. 2 rows and 3 columns. 2 rows and 3 columns. This is order of a matrix and size of a matrix. After that, there are different types of matrices. Matrices consisting of, there are so many cases. We are discussing that particular matrices. First of all, square matrix. First of all, we discuss the square matrix. Square matrix. A matrix is said to be square matrix. A matrix is said to be square matrix if the number of rows is equals to the number of columns. The number of rows is equals to the number of columns. That is called as a square matrix. That is, rows and columns both are equal. We are taken as an example 1, 4, 2, 5. It's consisting of how many rows? 2 rows. And how many columns? 2 columns. And which is of order? 2 by 2. The number of rows is equals to the number of columns. The number of rows is equals to the number of columns. That matrix is called as a square matrix. The matrix is called as a square matrix. After that, 2 by 2, 3 by 3, 2 by 2, 2 rows and 2 columns, 3 by 3, 3 rows and 3 columns, whatever it may be. Those are example for the square matrix. Those are example for the square matrices. The next one is a rectangular matrix. The matrix is said to be rectangular matrix. The matrix is said to be rectangular matrix. The number of rows is not equals to number of columns. The number of rows is not equals to number of columns. Row size is different from the column size. And the matrix is not a square matrix, which is not a square matrix. That matrix is called as a rectangular matrix. That matrix is called as a rectangular matrix. Suppose we are taking already example, this is 1, 4, 6, 2, 5, 3. We are taking as another example for this is A matrix, which consisting of how many rows? 2 rows. How many rows? 2 rows. And how many columns? 3 columns. How many columns? 3 columns. Got how many rows? 2 rows. And how many columns? 3 columns. So which is of order 2 by 3. Which is of order 2 by 3. 2 rows and 3 columns. The row size is different from the column size. The row size is different from the column size. That is called as a rectangular matrix, which is example for the rectangular matrix. The matrix which is not a square matrix, the matrix is called as a rectangular matrix. After that, row matrix. After that, row matrix. The matrix is said to be a row matrix if it consists only one row. If it consists only one row and contains a number more than one columns. Contains more than one column. But exactly which contains only one row. But exactly which contains only one row. Column number is so many chances, 2, 3, 4, whatever it may, but row size is only 1. That matrix is called as a row matrix. The matrix is called as a row matrix. We are taking as example 2, 7, 8. 2, 7. How many rows only? 1 row. How many columns? 3 columns. The order of the matrix is 1 by 3. The row size is 1. The row size is 1. Column is different. That is, which matrix is called as a row matrix? Which matrix is called as a row matrix? Which consisting of only one row. Which consisting of only one row. Which is the example for row matrix. And the column matrix. The matrix is said to be column matrix if it consists only one column. If it consists only one column. The row size is different as compared to this. It may be 1, 2, 3, 4, whatever it may. But column size is only 1. The matrix is said to be column matrix if it consisting of only one column. If it consisting of only one column, which is called as a column matrix. We take the example 1, 5, 6. Take the example 1, 5, 6. What is the order of this matrix? How many rows? 3 rows. How many columns? 1 column. Order of the matrix is 3 by 1, which consisting of 3 rows, only 1 column, which is example for the column matrix. Which is example for column matrix. That is a row matrix and a column matrix. The next one is a zero matrix or null matrix. Zero matrix or null matrix. In the name itself, zero matrix or null matrix. The matrix which consisting of all elements are zeros. The matrix which consisting of all elements are zeros. That is called as a zero matrix. That is called as a null matrix. Every element in the matrix is 0. Every element in the matrix is 0. And first of all, we will go for a small point. The representation of a matrix elements in the matrix, the representation. Suppose we take example A matrix. Suppose I am taking one example. The representation of elements in the matrix. How we are representing the elements. What is the order of the matrix? Which consisting of 2 rows and how many columns? 3 columns. Which is order is 2 by 3. 2 rows and 3 columns. But here the element 1 or the number 1 represent. How can you represent that 1? How can you represent 7? How can you represent 4? Here, which is 1. First element is 1. 1 is a first row element and first column element. First row element and first column. Which is represented as A11. Which is represented as A11. First row, first column. First row, first column. And 7 is represented as A12. 7 is represented as 1, 2. First row, second column. First row, second column. And 8 is represented as A13. First row, third column. First row, third row. The representation of the elements in the matrix like this. And this is a 2. 2 means which row? Second row. Which column? First column. That is A 2 by 1. Second row, first column. And 4 is represented as A22. Second row, second column. And 9 is represented as A23. A23. Second row, third column. Representation of the elements. So basically that is Aij, representation A. You can write it as a symbolic formation in the matrix. A equals to Aij. I represent for row size, J represent for column size. That is A00, A11, I value 1, J value 1, I value 1, A value 2, A12, A13, so on formation. That is a representation of the elements in the matrix. After that, next definition is unit matrix or identity matrix. Unit matrix or identity matrix. Very, very important. Which can be used in eigenvalues concept. Unit matrix or identity matrix. The matrix is said to be unit matrix. The matrix is said to be unit matrix. The diagonal elements are 1. The principal diagonal elements are 1. The remaining all elements are zeros. Remaining all elements are zeros. Which is called as a unit matrix or identity matrix. Here already we know that 1 0 0 0 1 0 0 0 1, which is called as a diagonal, principal diagonal, which is called as a principal diagonal. All the principal diagonal elements are 1. All the principal diagonal elements are 1. Remaining all elements are zeros. Remaining all elements are zeros, which is called as a unit matrix. Which is called as a unit matrix. This is a simple. This is order 3 by 3, which is of order 3 by 3, and which can be represented as I3. Which can be represented as I3. Always unit matrix is square matrix. Square matrix means the number of rows is equals to number of columns. But by default it is represented with I3. I3 means 3 by 3 matrix. I2, that is 2 by 2 matrix. 1 0 0 1. 1 0 0. This is simple definition. Generally it is called as a simple. Then otherwise, or it can be explained as the matrix is said to be unit matrix if Aij equals to 1 for I equals to J. Aij equals to 1 for all I equals to J. Aij equals to 0 for all I not equals to J. For all I not equals to J. Which is the main definition. This is a simple definition, which is the main concept definition. What I am explaining here, Aij equals to 1 if I equals to J. I equals to J. Already the elements can be represented as A11, this is A12, A13, A21, A22, A22, A31, A32, A33, A11, A22, A33. Row size equals to column size. I equals to J. I equals to J. A11, A22, A3. In that particular place, what is the value here? 1. That is Aij equals to 1. For I equals to J. For all I equals to J. And Aij equals to 0. Different numbers. A12, A13, A21, A23, A31, A32. All are different. All are different means what is the value here? 0. Which is called as a unit matrix. Which is called as a unit matrix. Most important one. Which is used in eigenvalues and eigenvectors. Which is used in eigenvalues and eigenvectors. Which is a concept for eigenvalues and eigenvectors. So many definitions are there, but most of the definitions, that is a only simple definition, can use in the eigenvalues and eigenvectors, which is very, very important. First, this is a simple concept. After that, the basic main, the definition of eigenvalues and eigenvectors. What is the definition of eigenvalues and eigenvectors? What is the definition of eigenvalues and eigenvectors? Suppose, let A, capital A, is a non-zero matrix. Capital A is a non-zero. Suppose, first of all, eigenvector, eigenvalues and eigenvectors. Suppose I am taken as a let A is a non-zero matrix. I am taken as a non-zero matrix. After that, X, let us consider as X, any non-zero vector, which is a is a matrix, X is any non-zero vector. X is any non-zero vector. And that non-zero vector is said to be eigenvector of the matrix A. A is a matrix, which is also taken as a non-zero matrix, and X is any non-zero vector. X is any non-zero vector. X is non-zero vector. Then that X is said to be eigenvector of the matrix A. Then X is said to be eigenvector of the matrix A if AX equals to lambda X. If AX equals to lambda X, then that X is called as a eigenvector. Then that X is called as a eigenvector. And lambda is called as a eigenvalue. And the lambda is called as a constant. Lambda is some constant. That lambda is called as a eigenvalue. That is the definition of eigenvector and eigenvalue. Once again, let A is a matrix, that should be a non-zero matrix, and let us consider X is any non-zero vector. Let us consider X is any non-zero vector. That vector is said to be eigenvector of A. That vector is said to be eigenvector of A if there exists a scalar lambda. If there exists a scalar lambda such that AX equals to lambda X. If such that AX equals to lambda X. In this case, X is called as an eigenvector and the scalar lambda is called as an eigenvalue. And the scalar lambda is called as an eigenvalue. These eigenvalues and eigenvector are also read as characteristic vector or characteristic root. Characteristic vector or characteristic root. Eigenvector, characteristic vector. Both are same. Eigenvalue, characteristic value or characteristic root. These both names are very, very important. Which is called as a eigenvector. Which is called as a eigenvector and eigenvalue or characteristic vector and characteristic value. After that, the next one is the characteristic equation. The next one is a characteristic equation. Characteristic equation. Let A be a square matrix. Let A be a square matrix. After that, then the equation. Let A is a square matrix. Then the equation. The determinant of A minus lambda I. Then the equation, the determinant of A minus lambda I equals to 0. Determinant of A minus lambda I equals to 0. Which is called as a characteristic equation. Which is called as a characteristic equation. Let A is a square matrix. Here every matrix is a square matrix. Square matrix means the number of rows is equals to number of columns. I will explain the definition. Here, then the equation. A is a square matrix. Then the equation determinant of A minus lambda I equals to 0. Determinant of A minus lambda I equals to 0. Where I is a unit matrix. Already we have discussed the definition of unit matrix. The principal diagonal elements are 1, remaining all elements are zeros. Principal diagonal elements are 1, remaining all elements are zeros. Which is nothing but unit matrix or identity matrix. Which is represented with the symbol I. That is I2, I3 by 3, I2 by 2, 2 rows and 2 columns, 3 rows and 3 columns. I is a unit matrix which is of order A. Which is of order A. Suppose A is 2 by 2 matrix, then we can take as I is also 2 by 2. Suppose A is 3 by 3 matrix, we can take as I is 3 by 3 matrix. But I matrix is always equals to the order of A. Is always equals to the order of A. Which is the definition of characteristic equation. After that, we are doing some problems. Problems on eigenvalues. First, verification for eigenvalues. Characteristic values. Eigenvalues means lambda values. Once again, I am repeating the definition. A is a matrix, A is a square matrix, and X is any non-zero vector. X is any non-zero vector. Then there exists a scalar lambda. Then there exists a scalar lambda, such that AX equals to lambda X. Such that AX equals to lambda X. In this case, that x is called as a eigenvector and lambda is called as a eigenvalue. Lambda is called as a eigenvalue. Here we are discussing the problems regarding eigenvalues and regarding lambda value. Lambda, some value for lambda is given, we can verify that is eigenvalue of that particular matrix or not. The verification of lambda value is a characteristic value or eigenvalue of a matrix or not. We are discussing the problems. Suppose the problem first, not for the lambda value, first x values, depending on the problem, first x values. Suppose the problem is given is 1, 4. The matrix is given is 1, 4. An eigenvector of the matrix is -3, 1. The second row -3, 8. Verification is 1, 4. Some matrix is given. An eigenvector of this matrix. Verify this matrix, this vector is eigenvector or not for this matrix. Suppose if it is eigenvector, find the eigenvalue. If so, find the eigenvalue. First problems. Verify this vector is eigenvector or not. Suppose we are taken as let A equals to this matrix. I am taken as let A equals to the matrix -3, 1, -3, 8. And I am taken as x. Eigenvector is represented with the symbol x. That is any non-zero vector x, and in the definition non-zero vector is x. But I am taken as x equals to 1, 4. This is A matrix is given and X matrix is given. We have to verify X is eigenvector of the matrix A or not. But what is the definition? I am explaining the definition. Eigenvector means that is there exists a scalar lambda. There exists a scalar lambda such that Ax equals to lambda x. Such that angle such that Ax equals to lambda x. For that we have to find Ax. Now to find the value of Ax. A means -3, 1, -3, 8. X means 1, 4. Multiply these two matrices. Now what is the condition for whenever we can multiply these two matrices? What is the condition? The condition for the multiplication of matrices, the first matrix column size is equals to second matrix row size. First matrix column size equals to second matrix row size. Then only you can multiply those two matrices. First of all, order. Order means how many rows? 2 rows. How many columns? 2 columns. The order of the matrix is 2 by 2. The order of the matrix is 2 by 2. Here, how many rows? 2 rows. How many columns? 1 column. What is the order of the matrix? 2 by 1. First matrix column size. Second matrix row size. First matrix column size and the second matrix row size are equal. Then only you can multiply those two matrices. Here the column size is 2. Here the row size is 2. I can multiply these two matrices. Ax equals to first row with first column. Matrix multiplication. First row with first column. -3 into 1, that is -3 plus 1 into 4. 4. First row with first column. Suppose another column is there, first row with second column, the matrix multiplication, but only one column. That's the reason first row with first column. After that we go for the second row. Second row with first column. -3 into 1, that is -3. 8 4s are 32. 8 4s are 32. -3 4, that is 1. -3 plus 32, that becomes 29. Which is the required answer. Ax equals to, we get 129. What is the definition? Ax equals to lambda x. Ax equals to lambda x. What is lambda? divide the lambda x. What is x value? 1, 4. Here we get 129. We are taking some common element. We get 1, 4. We can written as ax equals to lambda x. But 29 is a prime number. 29 is a prime number. We can't take outside. That's why reason not getting 1, 4. So ax is not equals to lambda x. X equals to not equals to lambda x. Suppose 29. Suppose we get in the place of 29, we get 28. 28 means suppose we are taking common. After that we get 1, 4. Some constant into x vector. That is ax equals to lambda x. Then only that is called as eigenvector. But here 29 is a prime number. We can't take outside. That's why reason ax is not equals to lambda x. Ax is not equals to lambda x. The condition fails. Therefore, the given vector is not an eigenvector of the matrix. The given vector is not an eigenvector of the matrix. This is a verification for finding the given vector is eigenvector or not. This is a process. Which is the process for checking the given vector is eigenvector or not. Suppose we go for the next problem, which is not a eigenvector. Is it clear? Suppose we take another problem. Is some vector is given 1, minus 2, 1. 1, minus 2, 1. An eigenvector of the matrix. First row 3, 6, 7. Second row 3, 3, 7. 3, 3, 7. Third row 5, 6, 5. The problem is once again asking the verification is 1 minus 2 1 1 minus 2 1 an eigenvector of the matrix 3 6 7 3 3 7 5 6 5. Suppose if it is eigenvector, find that eigenvalue, that is a lambda value. Okay, after first of all we are taken as let, which is taken as x and which is taken as b. X is an vector and A is a matrix. Once again, same condition verification, that is Ax equals to lambda x. We have to find Ax now. A means write the matrix 3, 6, 7, 3, 3, 7, 5, 6, 5, 5, 6, 5. Into X matrix 1 minus 2 1. 1 minus 2 1. First of all, you multiply these two matrices. The condition is first matrix column size is equals to second matrix row size. What is the order of this matrix? 3 by 3. 3 rows and 3 columns. What is the order of this one? How many rows? 3 rows. How many columns? 1 column. Here, first matrix column size is equals to second matrix row size. First matrix column size is equals to second matrix row size. Both are equal. Then only we can multiply these two matrices. Ax equals to multiply these two matrices. First row with first column. 3 1s are 3. Plus into minus minus 6 2s are 12. Plus 7 1s are 7. First row with first column. First row with first column. 3 minus 12 7. After that, second row with first column. Second row with first column. 3 into minus 2 minus 6 plus 7. After that, third row with first column. 5 6 2s are minus 12 plus 5 1s are 5. First row with first column, second row with first column, third row with first column. Ax equals to 10 minus 12 that becomes minus 2. 7 plus 3, 10. 10 minus 6, 4. 10 minus 12 minus 2. At lastly we get Ax equals to minus 2, 4, minus 2. Here there is no prime numbers. You can take common. What is X matrix here? X vector 1 minus 2 1. Based on this one we are taking some constant is take common out. Take common. I am taking here minus 2 is the common. I am taking minus 2 is the common. What is the remaining one? 1 minus 2 1. Minus 2, 1. Minus 2, minus 2, minus 2, that becomes 4. Minus 2 into 1, minus 2. I'm taking minus 2 is the common. We get 1, minus 2, 1. 1, minus 2, 1. It's nothing but minus 2, which is nothing but x. Which is nothing but x. That is ax equals to minus 2x. We get ax equals to minus 2x. That is ax equals to lambda x. Now, what is eigenvector definition? There exists a scalar lambda. There exists a scalar lambda such that ax equals to lambda x. Here ax equals to lambda x. In the place of lambda, here lambda, what is lambda value? Minus 2. What is the lambda value? First of all, it satisfies the condition. First of all, it satisfies the condition. Ax equals to lambda x. Therefore, whatever the given vector, that is an eigenvector, that is a characteristic vector, that is x vector 1, minus 2, 1 is an eigenvector of the given matrix. Eigenvector of the given matrix. Otherwise, characteristic vector also same. That is 1, minus 2, 1 is a characteristic vector of the matrix A. If it satisfies the eigenvector. If so, find the eigenvalue. Some question in the question, if so, if it is eigenvector, find that particular eigenvalue. In the place of lambda, what is the lambda value? Minus 2. What is the lambda value? Minus 2. And here minus 2 in the place of lambda, which is called as a eigenvalue or characteristic value. Eigenvalue or characteristic value. Otherwise characteristic root or eigenroot. Characteristic root or eigen. Which is the verification for? Which is a verification for verifying the given vector is an eigenvector or not. Given vector is eigenvector or not. First of all, it satisfies the definition. That is, A is a matrix. That should be always square matrix. Always we are discussing with the square matrix only. That is, the number of rows is equals to number of columns. After that, A is a square matrix and x is any non-zero vector. X is any non-zero vector. Then there exists a scalar lambda. Such that it satisfies the property Ax equals to lambda x. Satisfies the property Ax equals to lambda x. In this case, x is called as eigenvector and the scalar lambda is called as eigenvalue or characteristic value. Here it satisfies Ax equals to lambda x. Here lambda value is 9. Which is the model for finding the eigenvector of the given matrix. After, in the next class, we discuss about eigenvalue. Lambda value is given. Verify that lambda value is an eigenvalue of the given matrix or not. We discuss that particular problems in the next class, which is the first method. Okay, this is the definition for eigenvalues and eigenvectors. Okay, thank you all. Thank you.